How to edit and extend 3D objects using extrusion. Hello everyone, in this video I'll start introducing the first modification tool, which is extrusion. There's actually quite a lot to talk about extrusion. It's a very advanced tool and it's the most frequently used. They have a lot of settings, a lot of stuff. So if I start explaining simple theory and what everything means, it may take too much time. So I think I'll rather start focusing on some practical use case, and as we go explain certain things, and maybe I'll split some other in another video. So to get started here, what I'll do here is I create a basic cube where I sized it by 150 by 150, width and depth, height 20. I added segments only in two directions, the width and depth, and the height stays 1. And then I moved it up by 150 from the floor, so I'll have room here to move it down. Okay. So here's the concept. So this is lifted up on floor 150, and I want to add here legs. So what I'm going to do here is I'm going to select these 4 corners, and I'm going to start extruding them downwards. Now I can move them down completely 150, something like that, and you get a single segment extrusion and everything is fine. But I actually wanted to be able to extend here from one side to another side, so I'm going to make a multiple segment extrusion. Let me explain in a second what means multiple segment extrusion. So the extrusion, like most other tools in SelfCAD, does not allow you to change the selection. So whatever is selected, be it the complete object, or in this case faces of an object, this is the only thing you can work with until you finalize the extrusion, and then you can change the selection and enter it again. However, with the same selection, it could be a single face or multiple faces, like in this case, you can use them in multiple segments. So in this case, what I'm going to do here is I'm going to use the first segment as 65, and then in order to make a segment I have to click apply. Now if you think about what happens when I click apply, it confirms this is already done so that I can change now a different value. If I exit out, I cancel, everything will be cancelled. But if I continue going and I confirm it, this will be confirmed. So now what I'll do is the second value, I'll enter 20 over here and I click apply. Now it tries always to apply again the third segment, always make a segment the same value you entered before, so I always need to change it. And now I'll change it to 65, which is going to be the same as the top segment. Now in this case, because this is the last segment, I don't want to click apply. If I click apply, it will automatically make a fourth segment, and then once I confirm it, it will confirm the fourth segment as well. So the last segment, you don't apply it, you only use the confirmation icon, and in that case the confirmation icon will apply the temporary new segment plus the other ones that are already applied. You could still X out and everything will be cancelled, but in this case I want to finalize with the third segment, so I've applied the first and second, and third one is being just with the confirmation icon, and now I'm left with this. Okay, so now here is an interesting phenomenon where we have to understand how extrusion is working. Now whenever I extrude something, so let's say if I take this single face over here and take a look, we have 174 faces in total. If I extrude that by any value, it doesn't matter really the value, look what happened over here. We added additional 4 faces. Instead of 174, we have 178 faces. What happens here is that we add these 4 additional faces over here, and that's basically the 4 that was added. But what happened with the top face? It turns out the top face is not really a new face. It's the same face that was here before. Sorry, it was just moved up, and now you see we have the same face up here, so it didn't really add anything. If you're going to delete this face, for example, you will see there is nothing in here because this face was removed over here. You can see the back face you see over here, but the inside face actually is removed. It's hard to see maybe, but this face here was removed. You can see there's a hole over here. There's not, it's completely removed. And this is actually very important from the concept of keeping objects manifold, which a concept manifold or watertight, whatever name you go by. Basically that means is that the object has to be an uninterrupted volume. And if you have something here inside, it interrupts the volume, and that means the object is not really 3D printable. And also a lot of tools, for example, Stitch and Scoop or some other tools, wouldn't really work with these type of objects, which is one reason why other software, for example, Google SketchUp, they don't really care about this type of stuff, have a problem printing their objects, and they don't really have the Boolean tools because these things are need to have objects that are manifold, and SelfCAD actually does care about manifold, so we can use the mix of all of these tools together. Okay, so now let me show you why this is, why I'm talking about it, why this is important, because if we're going to extrude now this one, we know we always add, we move this face and we build only the side edges, but if I want this to connect to this one, actually I need to delete this face. this face needs to be completely removed. And not only this face needs to be removed, I can technically simply delete them and move the edges, but also this face needs to be deleted then. But not only the faces needs to be deleted, they also need to be merged vertices. And what merged vertices means is the concept that, let me explain what merged vertices is. So if you think about, let's say, any vertex over here, a basic object has only 6 faces. If I select this vertex over here, let's say, I've selected this. If I select, you see, if I select this, I have only 6 faces, but it has 12 edges and 8 vertices. If I select a single vertex over here, you see, I have only 1 vertex. And the reason here is because this vertex is repeated. It's used by this edge, by this edge, by this edge. It's used 3 times the same vertex. If I'm going to duplicate this vertex, like each edge will have their own vertex, this would be considered also a non-manifold object, and in technical terms this is called like exploded geometry. So what happened here is, if I'm going to have this object to connect them, I need to delete the inner face, plus I need to make sure these 4 vertices here and 4 vertices here are actually going to merge, so it's going to end up being a single vertex. So in most cases extrusion will detect that, it will know it, as long as the objects are completely like flat like this. If you have more complex geometries, you may need to use different tools, so I'll introduce that to it. I'm going to show you. So first of all, how do I know the exact value here? I don't really know the exact value between them, so I can actually go and measure them and enter the exact value, but I can also simply go here and snap it. You can see over here that once I go close to it, it gives me the option to snap. It snaps automatically. You can feel it when it gives a snap. In this case, I got a value over here that is 107.14. And let's take a look what I have over here. I have 174 faces as of now. So we know we're going to add these 4 edges from all sides, 4 faces on all these 4 sides, but I'm going to remove 2 of them. In this case, what needs to happen here is that I actually need to add only 2 faces. So I'll expect we'll have only 176 faces, only 2 added. As far as vertices, if you think about it, there's no vertex added actually, because all of these vertices that make up these side faces are already here from these faces. So actually I expect will be added no vertices. I have a total of 176, and I expect actually I'll end up having 176 vertices and 176 faces, the same amount. So let's see once I confirm that, and that's exactly what happened. There hasn't been added any vertex because these vertices are reused, and only 2 faces has been added. To illustrate it again, let's take a look. If I select this face over here, you see I have only 1 selected, but not only selection. Let's take a look. If I'm going to move that now, you see it's going to stretch all connected faces because this vertex has been merged. Okay, so this is basically the way you can do it over here. Now I want to connect the same on the other sides as well. So I'm going to go back here and select, let's say, this face and this face, and now I can reuse the same value. This will remember the same value already I've entered before, so this will be fine. But if I'm going to select, and this will work if I select only 2 in these directions, but if I'm going to select now the third one and this one that is going in a different direction, I'll have a problem here. And this is where the thing about direction goes in. So we have something about direction where it's going, and by default the direction is the direction of the face. It's not using, if you watch my other video about local and global coordinate systems, how to position 3D objects, I think is the title, something like that. I explained the concept about the XYZ coordinates, how it's local and global coordinates and so on. In the extrusion, actually, it's using something called face normal, which is the direction of the face. Now, the direction of each of these faces two faces have been going in the same direction, there's no problem. If you introduce another direction, which is going the other way, it needs to kind of use the average direction. And the average direction would be something like this, where you see the gizmo. This is where it points the average direction, and this is where, these faces will be extruding. So this is where you have the option here to use individual. So each one goes in its own direction. Now the gizmo will still be pointing in the average direction. It cannot point, we don't have 3 gizmos to point each one in its own direction individually. So it's kept as the average direction, so you cannot use them. But you can still enter the exact value in individual, and now you can finalize it, and basically this is done, and we added these type of segments. Now I want to show you how I'm going to do the top. So I can do the same, I think, with the top over here, that I want to add, let's say, over here, kind of selecting every second, and I'm going to extrude that something like this. Now I can extrude it again as 1 segment, and let's say 150 will be the total. If that should be the height, something like that. But if I want to add another segment over here, I can actually do the same thing I did before and make it, let's say, 65 and then 20, let's say, and apply, and then again 65. And now I can go and take these center pieces over here and connect them the same way I've connected these over here. The problem here is I want to bend this actually, and if I'm going to bend this, I'll have a problem because these are not these are difficult to bend because there's not enough details to bend. So let's take a look. If I'm going to bend this, it'll kind of, you know, bend only here in the center, and this would look probably not the way you want it to see. It's not very smooth the way this is bended. So what I'm going to do here is I'm going to use repetitive extrusion, which is similar concept to apply, but you can automate them. You can do a lot of things automatic. So what I'm going to use over here is I'm going to want to make this in 20 steps. Now with repetitive extrusion, you can add options to add transformations, like each step should scale, or different extrusions, different transformations, or everything you can do. For now, all I want to do is just add steps. I want this to extrude in 20 steps. So what I have to do here is I have to subdivide the total amount of 150 into 20, which gives me 7.5. So I'm basically going to say, okay, so extrude each step by 7.5, but repeat it 20 times. And then I click the confirmation icon to confirm it, and look what we got over here. So we get now this. I'm deselecting this, and I'm going to select all of these faces. Here I want to show you another concept, which is how you can use marquee selection. Now marquee selection will be used, I've shown it in another video. We'll select everything that is visible. In this case, these faces are visible, some side faces, like this angle was side visible here, not. Some front faces, but none of the back faces. So in order to select the entire thing at once, there are other selection tools, for example, like cube selection, but I'm not going to go into it. Now for marquee selection, I'm going to use the wireframe mode, and I can go to the back, snap it over here, so it's flat. And because I make it wireframe, it can see through everything. So now I should be able to select everything with a single stroke. And now you can see everything is selected. So I can go back to my wireframe plus this. And now I can go and bend that something, I don't know, exact value, but let's say 15 should be probably fine. And now I gave it some angle. So now once I gave it some angle, I can do the same thing that I did before, where I'm going to select here two faces, and I'm going to extrude them by snapping it to it. Okay, so it gives me a value 21.43. Doesn't really matter the exact value because I'm simply going to reuse the same amount, so it remembers it. And here's a little bit of a danger, because when you use these transformation tools like bending, all this type of stuff, I've shown a previous video where we have dynamic origin. It's sometimes shifting a little bit. You have no guarantee without dynamic origin, or even with that maybe, you have no guarantee they're 100% accurate, all of them. So it's possible something will not be snapped correctly and one of the faces would be duplicated. So just for a safety precaution, what I'm going to do here is I'm going to use the geometry clean to have an option to remove duplicates. Which this means if the faces are, some vertices are not merged. Cut intersection is not needed over here, there's nothing to cut. I have another video about geometry clean, you can look up what this is. And remove inner faces, this is the faces that I've shown here inside. And let's see if it does something, and actually it did remove some vertices. So it looks like there's all of the inner faces has been removed, but some vertices have not been merged. So if you do things like that, it's always good to double check, just in case there's some vertices not been merged. Okay. Now I want to show another example for cutting, which what I did until now, actually, it's not really cutting, it's just removing the inner faces, snapping to it and removing the inner faces. Now I want to show you an example of actual cutting. So if I'm going to take these faces over here, for example, and if I move this down, let's say extrude this by whatever, let's say 10 should be enough for this, and I want to extrude it like this. Now it looks fine, and if you do it in a certain software, let's say for example SketchUp, this probably would be fine. This is how it would look. But if you think about the manifold geometry, and if you want to be able later to use tools like Boolean operations, this needs to be manifold. This would not be fine because this is not a proper volume. The volume here needs to go into this. It needs to be fully connected. So there needs to be a cut over here. And once I finalize, this will actually create a cut. And you see over here, it created a cut. This connecting over here. So basically, this is now a manifold geometry, completely manifold without a problem. And this is basically it. To demonstrate another thing about cutting, I'll show you quick another example, and I'm going to hide this away and just take another option, another cube over here, a basic cube, and I'm going to show a concept using the Inset tool. So the Inset tool is basically a tool that will just kind of inset, make an inset. It's not really a very advanced tool, it's just very basic. You make an inset. It creates a cut like this without extruding, without anything. I can later extrude them, for example. I can later, let's say, move them, just use them to stretch faces, whatever, or I can use them to extrude, for example, something like this, and start building them out. That's fine. But if I'm going to extrude them till it touches over here, I can either snap it over here, or I can type it in. I know the value is 100. It will actually make a cut and remove this face completely. If you stick it out the other side, like invert it from the inside out, this actually would not work. This will make it non-manifold. You cannot extrude to come out completely more than 100. This actually will make it, if you do something like this, this means this object is not manifold. If I turn on, for example, my back face coloring, you'll see actually this is inside out. This faces over here has been inverted and flipped, and this is not manifold. But as long as you do it completely 100, just the exact value, this will create a cut. However, it can only cut a single value, a single face at a time, and only if it perfectly aligns. So if you have something that is twisted, bended, this will not work, or if you have multiple at once. So let me show you an example. So once I cut this, and let's say I want to do this over here, the same idea. So I'm going to inset this, and now I want this to cut through. So if we're going to use extrusion now to cut 100 to the side, this actually will not work, because it needs to cut not only this face, but it needs to cut also this face and also this face. So it has actually 3 faces that it needs to cut, and this is limited to cutting 1. So if you have an example like this, you can do it in 2 different ways. One way could be, you could just copy this face, and then you can add thickness to it to basically build them out, let's say 150, just to give it a random value, and it's mirror thickness, so it sticks out on both sides. And now I have this new object. This is basically a complete new object now, and now I can use the Boolean operation tool. So I take these 2 tools, and these 2 objects, and I remove this object, and now you can see this is cut perfectly fine, and from all of the sides. But you can see also this geometry, it's completely rebuilt the object, and it's not as nice as I would want it to look like. So, but in some cases, if you have complex geometries, to make these type of cuts, you will have to use the Boolean tools. It's the only way to do it. But in this case, I can actually do it in different ways. So I'll remove the copy also. So what I'll do here is I'm just going to extrude this by this amount, which is, I think I remember it was 10 minus 10. So now, no, actually it was 20. Let's see. Yeah, it was 20. Snap there, hits 20. And now this cuts this one. And now I'm going to do the same thing over here. I'll select this one. I'll inset this, and then I'll extrude it by -20, and I did a cut. So basically what I did is I divided into 2 sections. This face cut only this one. Now I did over here, this one cuts this one. So the cutting from extrusion is limited to cutting simple things. If you need more advanced, there's always the Boolean tools, and the easiest way is to simply copy the faces and add thickness to it and kind of use it in that way. Okay. Another thing I want to show here is some other extrusion examples. I guess I can get rid of these objects. What I want to show here is another example with using side extrusion. So let's go take an example. I'm going to use a simple screw. You can do a nut and screw, but if you drag and drop, it will give you a single screw. And now I'm going to select the entire top. I'm going to switch to my polygon selection so I can select the entire top. And I'm going to extrude that. Now, here I need to extend it outward. So this is where side extrusion comes in. I can make side extrusion for not negative, positive. So let's say I make this something like this. Now, once I finish with this is also not manifold. These faces are just like overlapping one on top of each other. And this actually is not good. But if I apply and add a second step is not side extrusion, and now do something like this, this actually creates something like this. So let me explain what happened. So when I did the first extrusion, it added this face over here, just sideways. And this sideways by itself is not doing anything. It's just overlapping on top of the other face and extending. It's not manifold. But once I move this up to create this, actually this face was created initially. This was the face that was created, and it was laying over here. So, but once I moved that up, what happened here is we actually added only this outside part of it. This entire face was moved up. It added the side faces over here, and it also added this face. So in this particular case, the extrusion actually added bottom faces as well, but only this half of it. So if you see, if I'm going to copy these faces and move it away, you're going to see it added like just exactly what it is that has a hole. So let's just move this out of the way. You can see it added faces like this. So this is where Extrusion is actually quite advanced, that it knows what to do and where to copy and what to do it. So let's redo it again so we can watch what's happening here is. So let's undo this entire thing. And again, I've selected these faces, and let's do now extrusion, side extrusion by 20. So I'm going to finalize it now, and I'm going to copy this face, just to copy it and see what's happening, and I'm going to move it away. So you see over here, it actually added this entire section. So, and this is basically not manifold, it sticks over here. But once I do, let's just undo it again, copy, okay. But once I add the second extrusion to it, this is actually being solved because this is being moved up, and then it's being added, and now it's done. Now I did it now in two separate extrusions, and the first time I did it just using apply, it's the same thing, it doesn't really matter, but now I got this. Okay, so now I want to show you something interesting. What I can do over here is I'm actually going to use Inset again, and to give it some value, let's say 20, I'm fine with it. And now I'm going to use the flatten tool to give it some value. So I'm going to use it let's say these two values. Now I wanted to use key proportion, these type of stuff, but I don't need it. This over here, it's good. I'm going to enter over here the value to flatten this to, let's say 75. Okay, so this is how I got it kind of rectangular. And now we're going to use extrusion, either extrude something like this. You can start building up if you want to make a screw like this, or you can make a negative extrusion, let's say minus 10, and now you can use a screw like this. So this is how you can start building a lot of these stuff. Now, in case you want to have here, let's say a Phillips head screw or different type of screws, you can use different tools, for example, cut with profile or Boolean tools later, but this is not the topic of this video. I think the last thing that I did not cover is the idea of Vertex Normals. So let me show you another basic example. So let's say if I take a basic cube here, and I'm going to extrude this by, let's say 2 steps of each one 50, let's say. 50, apply, and then finalize. Okay. So now what happened here is if I'm going to select, let's go to face mode, not polygon. So okay, I'm selecting these faces. If I select, let's say, all of these faces, I have an option to go, if I go extrusion, this is basically the way they each work, because if I have a complete loop, the average would be kind of in this direction. This is the only way it can work. But I can also use Vertex Normal, which in this case, it creates something like this, where, yeah, this kind of creates this cut. And I think I can use Vertex Normal negative, or maybe not, I'm not really sure. But if I would use, for example, select not all of them, let's say only 3 of them, now I'll have another option. So individual actually would work. Vertex Normal would also work, but give me this kind of behavior over here. And if I use individual, not Vertex Normal, just individual, I have this option connect neighbor, where I can kind of create these connections and so on. So basically here, in short, the cut intersection, see over here, these options are all these advanced features I've shown before, the way it cuts. And cutting means sometimes where it needs to actually create a cut, a split in geometry, and sometimes just to remove faces that needs to be removed. And then Vertex Normal and individual and connect neighbors on if you have individual. These things are talking about direction, which direction it goes. And then we have the side extrusion, which is what I've shown before. In this case, you have no use of it, but I've shown an example with a screw where actually it can extend sideways. And a side extrusion actually is quite similar to Inset. So if you use side extrusion outside, you can start building something like this, apply, and then with outside extrusion, you kind of start building something like this. But if you use negative side extrusion, let's do it again. Side extrusion, let's see, side extrusion, let's make it minus, let's say 20. It actually is the same thing as Inset. So it's basically, look how this looks like, something like this. If I would do Inset on this face, it would be the same thing. Inset 20 is the same thing. But Inset cannot go negative, only positive. So yeah, you could think about negative side extrusion is like an Inset tool. That's basically it. I think I covered quite a lot and jumped into the other tools as well. But I hope this was helpful, and extrusion is actually one of the most used tools. There's more advanced stuff. We have some tutorials for it as well, where you can use macros to create really nice objects. And then we have path extrusion, which is really exciting, but I think it's too much for this video, so we'll leave it here. Okay, thank you for watching. Let me know if you want me to show anything else. Thank you, bye.